Okay, welcome to a walking, talking mock for science. This is really for combined science as well as the triple scientists, and we're going to look at an example of a higher tier question or a higher demand question for biology, and particularly looking at how we tackle 6-mark questions and calculation questions too. So very quickly then, so let's make a start. So this question is about testing starches for leaves for starch, and one of the stages in this is ethanol is flammable, so should not be heated directly. Give one way ethanol can be boiled safely. Do not refer to wearing goggles. Right, so how are we going to heat this safely? Well, the easiest thing to do, and what you will have done when you did this practically in school, is you just heat it in a hot water bath. So you would heat it in a hot water bath. Okay, nice and safe because the steam is going to stop that from boiling. Right, next question is then about the test for starch. So what's the test and what is the result? Well, the test is you use iodine solution, and the result is it goes a blue or black colour. So nice easy starting questions. Right, the next question is a required practical question for chemistry as well as really biology, which is about chromatography. So what happens with chromatography? Well, it says explain how it causes the different pigments to separate. So what's the process behind the separation? Well, what happens first is you've got the paper goes into the solvent. The solvent will move up the paper. Now, strictly speaking, we should probably call this the mobile phase and call this the stationary phase, but we're talking about the process rather than talking about the specifics of the names of these. So what happens? Well, you've then got a combination of different factors. So you've got a difference in the solubilities, you've also got a difference in the interactions with the paper. So the pigments will have different solubilities in the solvent, and they will also have different attractions to the paper. You could call this adsorptions to the paper, but different attractions to the paper, so that moves them different distances. They are carried different distances. Where are the scoring points for this? Well, the first one is basically the solvent moves. Either one of those is going to be worth a mark, and that's the so bit at the end. Okay, the explanation bit there. Right, moving on. Right, now we get to do a little bit of calculations on this. This is to do with the RF values. So it shows you a bunch of different bits of information here. There's 2 RF values which it doesn't give you. We've got a green pigment that was found in the green and not in the red. So one pigment was found in the green but not found in the red. Why is it not possible to say what it is? Use the information to help us. Right, so let's have a quick look. Well, what is the green pigment? It's got an RF value of 0.2. Now, RF, if you can't remember, is the distance moved by the dot divided by the distance moved by the solvent. Right, so there is your chromatogram. You've got your line at the bottom. The solvent marches its way up and you mark the solvent front, and the dots move the distance up there. And if I measure that distance, that's the dot. If I measure that distance, that's the solvent front, and that divided by that is always going to be less than 1. So how do we not know what it is? Because it's got an RF value of 0.2. So what's got an RF value of 0.2? Well, I've got ranges. So chlorophyll B is 0.2. Xanthophyll is somewhere in the 0.2 brackets as well. So why don't we know? Because I've got an overlap in those 2 values. It could be, so there's an overlap between the values of chlorophyll B, and xanthophyll. Right, and that's the problem. So 1 mark, easy peasy. The experiment was repeated and the solvent front travelled 140 millimetres from the start line. Right. Okay, calculate the distances where the pigment carotene would be seen. Now the thing about this question actually is that it's not a particularly useful question to actually to do. No one in reality is ever going to ask you to do this, but it does seem to be a favourite in these sort of questions here. So what we're trying to do is to find out the distance moved. So I need to start off with the equation first. So RF is the distance moved by the dot, or the substance, divided by the solvent front. So, what do I know? Well, I know what the solvent front is, and if I go back to carotene on my previous part of the question, carotene has got a value of 0.89 and 0.98. So, if I want to rearrange that, I know what the RF value is, because the RF is 0.89 to 0.98. So I've got the RF, I've got the distance moved by the solvent, so I'm going to rearrange those two. So the distance moved by the dot, I'm switching pen colour, sorry. Is going to be the RF value times by, because change the sign, the distance moved by solvent. Right, so what's that going to be then? That's going to be equals 0.89 times 140 millimetres to, because we're trying to work out the range of them, to 0.98 times 140. So that's going to give me somewhere in the region of 124.6 to 137.2. Those are your two answers. Okay, so equals 124 equals 137. Okay, and there's your marks there. So what are the marks actually for? Well, if you get the answers right, you get all 5 marks, but you get a mark for that, you get a mark for that, you get a mark for that, and there's your answers there. So rearrange the equation, gets you a mark, plug in the right numbers in, getting the right answers, bing. So 5 marks. Right, moving on then. The next question is the 6 marker. And the thing about 6 markers is you've got to be very careful with the command words here. So this one is explain how they could have evolved. How plants could have evolved to contain more than one pigment in their leaves. So the thing about this is to get a level 3 answer, we're looking for relevant points identified, given in detail and logically linked to form a clear account. For level 2, which is 3 to 4 marks, relevant points are identified and there are attempts in logical thinking, but is not fully clear. For level 1 answer, 1 to 2 marks, we've identified some points that have been simply stated, but the relevance is not clear, and there's no attempt at particularly logical thinking. So, what's evolution all about? This is about things evolving. Why might that happen? Well, let's work backwards. Evolution is all about this survival of the fittest. If an organism is better adapted to its environment than another one, then it is more likely to survive long enough to pass on its genes to the next generation. So, where does this survival of the fittest come from? It comes from variation, and the variation is caused by randomly occurring mutations. So there's randomly occurring mutations will mean that that plant has more pigments than another plant. So it's probably more likely to survive because it can absorb a wider series of wavelengths of light, which means it's got increased photosynthesis, so it can outcompete neighbouring plants because it can grow faster and is more likely to survive in changing conditions. So here we go. It's worth 6 marks. I want to aim for about 6 minutes on it. I've kind of got a plan in my head. So how's that evolution happen? Well, the first thing I'm going to start to talk about is the fact that evolution is caused by these random mutations. So evolution is caused by random mutations in genes which causes variation, e.g., for example, more pigments. So, what might that do? Well, different pigments may be able to absorb a wider range of wavelengths of light. Wider ranges of light, which would increase photosynthesis. So what? So that would allow them to grow better. So this could cause increased growth, faster growth, which would allow them to outcompete neighbouring plants. And possibly to survive in changing conditions and be more able to survive changing conditions. Right. So what does that mean? Well, they're more likely to survive. They're then more likely to be able to pass on their genes to their offspring. These plants would be more likely to survive to reproduce and pass on their genes to their offspring. And that, in a nutshell, is what evolution is all about. So we have random mutations occurring, and so that might mean more pigments. Those pigments might allow them to absorb more light or more wavelengths of light, which means they can reproduce, photosynthesize better, which means they could grow faster, which means they would be able to outcompete neighbours. They'd be able to grow and get their leaves up above the surrounding canopies. They could get more light, bigger roots and all the rest of it to absorb more water, and they'd be more likely then to survive long enough to reproduce. Right, that would be, having chopped off the bottom, there it is. You see the bottom there. A good 6 mark question because we've got all the points clearly linked, and there's a real cause and effect going through. So that's answered that question there. We'll stop on that one. We'll have a look at the next question next time.